Hello, class. Today we'll look at another concept called continuously compounded interest. And as you can imagine, it's got compounded interest in it, so it has to do with something with the formula that we derived last time with about compound interest. And I have here the definition. So we said compound interest was defined as P times 1 plus R over N all raised to the NT, where P was the principal, R was the interest rate per year, N was the number of times compounded per year, and T was the number of years. Now, this is the question. We recognized, or we saw from the previous video, that the more times you compounded your money with the bank, the more money you received. So comparing when you compounded yearly to compounding daily, we saw from that example that compounding daily was more profitable than compounding yearly. You earned more money. So the idea is, can we go beyond daily? Think about compounding instantly. So every instant your money is being compounded. Right? That every moment, every second, millisecond, every instant of the day, your money is being compounded. So if you think about how many times that is a lot. All right, that is close to infinity. So thinking about every moment, every instant, if you count what every instant means, that's close to infinity. All right, so we need to modify this expression a little bit, and let's see if we can incorporate what it means to compound instantly. Every single instant, your money is being compounded. All right, so let's do this. I'm going to assume this definition. I'm going to let M be equal to N over R, meaning that N is the same as M times R. Okay, so now let's see what we have here. We have A, the amount, as the principal, times 1 plus R, and in place of N, I'm going to replace it with M R. Then in place of the N, I'm going to replace it with M R times what? Times T. Now let's clean up this expression a little bit so that we can see some interesting revelation. And then I'm going to apply, well, let's keep it this way and then we'll do that in the next step. I'm going to apply some rules of exponent over here so that I end up with 1 plus 1 over m all raised to the m, and then if I apply my rules of exponent, I can raise all that to the RT, which means exactly the same as the second line I have over here. Now, let's see if you recognize what is inside the red parentheses. Let's take that out for a second, and let's see 1 plus 1 over m all raised to the m. If you recall, that looks close to what we defined E as the limit as m goes to infinity. If you think about how we defined E from the Khan Academy video, it was defined as the limit as 1 plus 1 over m raised to the m is. So the idea is, as m becomes bigger, thinking about m being instantly being compounded, you can clearly see that if m went to infinity, that whole expression in the red parentheses will now become P E to the RT. So we're going to define continuously compounded interest as P times E raised to the RT, where P again is the principal, R is the interest rate per year, and T is number of years. So let's look at this example that I have over here. The example is you have $1,000, you invested at an interest rate of 12% for 3 years. And the question is, if we compound it continuously, then this is the equation that you end up getting. You get 1,000 times e to the 0.12 times 3. And when you calculate this, you end up with 1433.32. And if you compare that with the example that we did with compounding daily, when this was compounded daily, when $1,000 was compounded daily, for 3 years at 12% interest rate, the resulting value was 1433.24. So there is a slight increment for compounding daily, instantly. Okay, so it seems like the better option is when you go to the bank, you tell them, I want to compound my money instantly, continuously, and you earn more money than you would if you did it daily. All right, I hope this was helpful in learning how we compound continuously. All right, see you in the next video.